Hello and good afternoon. Welcome to the new episode. In this episode, I'm going to solve 4 different questions, which these questions for IGCSE level. And I have cited these questions from different series and from different numbers. So you may see these questions are cited from 2016 June 31, and the second question is November 33, and the next one is 32 paper number and from June series, and the next question is which is the last one, it's question 7, all same year 2016 series November, paper 42. So we have today 4 questions. We will solve them because they are covering different skills, which it's covering paper 3 and paper 4. So let's start with the first question. This question, the table shows some properties of the group number 1 metals. So here we have group number 1 metals. They have listed lithium, sodium, potassium, rubidium, and cesium. There is a density which is measured by gram per cubic centimeter, and melting point, boiling point, both of them are measured in Celsius. Question I. Describe the trend in boiling point of the group 1 metals. Here is the melting. Sorry, it's boiling point. Okay. You may see as you go down, the boiling point is decreased. So is decreasing, you can say. Decreasing down the group. Or you may say increasing up the group. Next question, predict the density of cesium. The cesium, any value between 1.6 to 2.5 gram per cubic centimeter. Any value 1.6 to 2.5 gram per cubic centimeter. So that means 1.7 is accepted, 1.8 is accepted, and till 2.5. So all of these answers are accepted. Deduce the state of cesium at 20. You have 20 cesium, it melts at 29. That means this temperature is before the melting point, so it's a solid. Explaining because (20°C) is less than melting point. Next question, complete the word equation for the reaction of rubidium with the water. Any metal with water will form rubidium, that means the metal hydroxide. So it's rubidium hydroxide with hydrogen gas. Hydrogen. The dye indigo tin is formed when compound F is exposed to air. The structure of compound F is shown below. Here we have this compound. This formula, it's called in the organic chemistry, it's displayed formula, because you have shown all the carbons how they are bonded with each other. So here complete the table and calculate the relative molecular mass of compound F. So some of them are done before, so just you need to fill this table. So here a number of atoms of hydrogen, 1 2 3 4 5 6. Atomic mass of hydrogen, it's 1, so it's 6 times 1 equals 6. For sodium, only you have 1 sodium, and it's 23. So 1 times 23, this one equals 23. Then you need to calculate the total of this one plus 6 plus 14 plus 16 plus 23, which is equal to 155 gram per mole. In the next question, it's about chromatography. You have 3 dye mixtures, J, K, and L. J, K, and L. All of these are mixture. So it's very clear they are mixture because they are containing more than one spot. Were spotted onto a piece of chromatography paper. 3 pure dyes, X, Y, Z. X, Y, Z. They are pure. Why? Because they are containing one spot, so they are pure spots. Were also spotted onto the same piece of paper. That means here we have in the first 3 are mixture, and these are pure. Actually, they are reference. So suggest why the baseline was drawn in pencil and not in ink, because ink would be dissolved and sprayed. Okay, so to avoid mixing the dye, which is you might find it in the ink, with this mixture and these pure substances. So always we are using the pencil because the pencil mark wouldn't separate, only the ink. So pencil, always you have to use it to draw the baseline. So this one, this line, it's base line, and this line it's front solvent. Okay. Now, next question: which dye mixture, J, K, or L, contains a dye which didn't move during this chromatography? The one who the spot who doesn't move or still on the baseline, that means this spot it's insoluble in that solvent. So we can see it's very clear in the K there is a spot it's hasn't moved, so it's K. Next question: which dye mixture, J, K, or L, contains both dyes? That means both dye X and Y. So this is X. So X dye you may find it in K and J. K and J. But the question should be also Y. This one it's Y, you can find it only in J, so J. The next question: which dye mixture, J, K, or L, doesn't contain dye Z? Where is Z? This one, Z. Here the question doesn't contain. L contains Z, K contains Z because they have same RF. But in the J we don't have a spot which having the same RF of Z, so the same result here, the same which is J. Next question: here you have jelly is a mixture of water and protein chains. As here we have stated, water is trapped between protein chains. A crystal of blue dye was placed on top of some jelly. After 30 minutes, some of the blue color could be seen in the jelly. After 1 day, the blue color had spread out further into the jelly. So here, use the kinetic particle model of matter to explain this observation. So what's happened here? Which process? It's diffusion. It's diffusion. Yes, first of all, before the diffusion, this crystal should be dissolved. So here we have dissolve, then the diffusion, okay, because there is no diffusion for something insoluble. So first of all, the crystal of blue dye should be dissolved in the water, then the diffusion process has been started. So when diffusion started, that means particles are moved. Then what's happened when they have moved? Then spread out. So because the question is 3, so you need to talk about the 3 points. So sometimes you may say the particles are moved from the high concentration to the low concentration, because it's always this is a diffusion. So it's just you need to talk about these 3 points, okay? And in the mark scheme you may find more than one, and these 3 options you may use them always, but the most important one, this diffusion, okay? The next question, the diagram shows the color changes of the indicator bromo cereal green at different pH value. So here, if you haven't heard about this indicator, it doesn't matter. Why? Because already here it's explained the change in the color in a different pH, in a different medium. So the question, it will be from the diagram. So here from pH 1 to pH 3.8 it's yellow. That means here we have strong acid. From 3.8 to 5.4 it's weak acid. That means it's green. And from 5.4 to 8, that means here in this region it's covered the weak acid and the neutral one and the weak alkali. So let's see the question. Predict the color of a bromo cereal green in a pure water. Pure water, it's pH 7. pH, it's 7. So 7 here in this region. So what's the color? It's blue. In a strongly acidic solution, the strong acid, it's not this one. Here the strong acid. So it's yellow. Next question. Here the concentration of an alkali can be found. That means the alkali has unknown concentration by titrating it with acid using the apparatus. So acid here known concentration, and here unknown. Always the known one should be put it here in this apparatus, and the unknown should be put it here in the conical flask. So the question I state the names of the piece of glassware labeled A and B. A it's pipette, and B it's burette. And then describe how you would carry out the titration using the apparatus shown. So here already the alkali is transferred to the volumetric flask here. Volumetric flask, okay? But before starting any titration, you have to add what? Some drops yes, some drops of indicator. Okay, so this is first one. Then this step slowly, okay, slowly add, what do we have in the biorate? Slowly add the acid. And this is the second And the third one, when the color of indicator changed, at once close the tab. So here, just repeat it. Okay, so here you have to talk about these three options. So always we have filled the biuret with the acid, which is known concentration, and the alkali that we need to determine the concentration. But before starting the titration, you have to add some drops of indicator to know the equivalent point, to know when the acid will neutralize the alkali. Then slowly add the acid. When the color of the indicator it will be changed, at once you have to close the tab. Here we have a question. Chlorine, bromine, and iodine are halogens, group number 7. The melting point of bromine is -7. So at -7 it will be changed. That means -7. It will be changed from solid to liquid. The boiling point of bromine is +59. At 59, that means you have liquid to gas. Okay, deduce the state of bromine at +6. So explain your answer. So at +6 is liquid. Why? Because the boiling point, let's remove this one. Boiling point here. Sorry. Boiling point is -7 and melting point is 59. Okay, and +6, it's located between these two values. Okay, in the next question you have complete the word equation for the reaction of chlorine with potassium iodide. Chlorine plus potassium iodide, because the chlorine is more reactive than iodide, so you have potassium chloride and iodine. And the next question suggests why iodine doesn't react. Why iodine doesn't react with potassium bromide? Why it's no reaction? Because iodine is less reactive than bromine. Okay. And the next question, we have another indicator, lethal fast yellow is it's a dye actually, and here we have this table, and also you need to calculate the relative atomic mass. Some of the atoms are done. So here, how many oxygens you have? You have 4 oxygen. So they're 32 times, it's 64. So 4 times, sorry, this is a total. So here 16. So 4 times 16, this one equal 64. And the chlorine, how many chlorine? You have 1, 2. So you have 2 chlorine it's the one of them, it's 35.5, so 2 times 35.5, and it's equal 71. So the total of these results, actually it's 357 gram per mole. This is the relative molecular mass of this dye. Here in this next question, again about chromatography, is used to separate a mixture of dyes. Draw a cross on the diagram to show where the mixture of dyes is placed at the start of the chromatography. So always you need to put your mixture where? On the baseline, which is drawn by pencil. So here, baseline. Pencil. Always we need to use the pencil because, as we have said, pencil mark wouldn't be dissolved or separate. So suggest a suitable solvent that could be used. Could be ethanol, could be any organic solvent. Describe what you would observe. Here we haven't used the water because this compound is organic compound, so you need to use ethanol, any organic solvent. Describe what you would observe as the experiment proceed. Dyes are move up and separate out. This is what you are going to observe. So in the next question, here you have proteins are major constituent of food. Proteins are polymers. What's polymer? Polymer, it's large, huge compound which is made from small units. What are these? Monomer. Okay. Protein can be converted into amino acid. That means how you are going to break down the amide link between the proteins. So here you need to make hydrolysis, and the hydrolysis could be in which condition? Acidic, or by using enzyme. Okay. And here in the next question, a colorless mixture. Here, colorless. It's very important question, this one. Colorless mixture. That means here this mixture, it's not dye. It's colorless mixture of amino acid was separated by chromatography. Amino acid X has an RF of 0.8. The chromatogram, that means the result of the chromatography paper of the mixture after treatment with locating agent. Here it's locating agent. What's that mean with locating agent? Because your mixture, it's colorless, that means there is no color, you will use locating agent. That means the locating agent, it could be as a solution of another chemical compound, will make these spots which are colorless to be colored. So it's locating agent. That locating agent will find these colorless spots. Okay, so how is an RF value calculated? RF value calculated how? Distance of the spot, we can say, or of the spot over the distance of solvent from baseline to solvent front. So for example, this distance, it's 10, and this one could be 8. So the RF of this one, it's 0.8. So what's the X here in the according to this question on the diagram? Put a ring around a spot caused by amino acid, because here we said it's 8 over 10, 0.8 it will be. So this is X actually, this is spot. And here describe how you would perform chromatography experiment to produce the chromatogram. Shows, assume you have given a mixture of amino acid and suitable locating agent. Here just you need to say here in the first thing you need to put your mixture, or what we can say, yes, mixture actually. Here, just 1 minute, let's draw a chromatography paper. Okay, in this chromatography paper you have baseline here. So first of all, spot the mixture on the baseline. So for example, here we have, okay, then immerse this chromatography in a beaker contains a solvent, and the level of the solvent shouldn't be higher than the baseline. So solvent, for example, water or ethanol, okay, it depends on the type of compound, and then you'll observe, as we have said, moving up and separating out. Okay, this is, you'll observe that. And in the next question you have when one molecule of amino acid A combine with one molecule of another amino acid B, two different dipeptide, that means peptide contains two amino acids, could be formed. That means this A could be bonded from, that means you will bond this side of A with this side of B, or you can bonded this side of A with this side of B. Okay, so you will get two peptides. So the first one, so let's start with this one. Here we have NH, sorry, okay, NH here, this is shaded box, and from carboxyl you remove OH, and then this H, then this empty box with carboxyl. So this is first peptide. The second peptide, as we can see here, you will bond it this side with this side. So you will start, you need to invert this compound. So this is the shaded one. You will put the N here, and here carboxyl. Okay, and this one, it will be bonded with this one. Also you need to invert it. Then the empty box with NH2 So both of them are peptide. How we have formed it? That means a molecule A from right side is bonded with amino acid B from left side. Then the second peptide, we have bonded amino acid A from left side with amino acid B from its right side. So you have formed two different peptides. Okay, so maybe you'll ask, they are same? No, actually they are different. Why? Because these boxes, for example in this one, this boxes, it's ended with amino group, but this boxes is ended with carboxyl group. So these boxes are different compounds, that means different carbons. So here we have drawn two peptides. So by the end of this session we have arrived actually we have to end this episode. So what I want from you, you have to watch this episode many times, and also you may click on the mark scheme which is attached to this video to check your mistakes, and also to mark yourself, to know how to mark yourself, because marking is the best way or the key of success. That means practicing, correcting your mistake, and marking. Why? Because always when you will mark your paper, you will challenge yourself to aim for high mark or for high mark. So see you in the next episode with a new test, with the new questions. See you again.